All right, so the lesson today is about comparing graphs of functions. And for those of you who are gone, this should help you get caught up. So the first graph we want to look at is this one on population growth. And you can see it's about two different cities, Baltimore and Cleveland, in the 20th century. So that means it goes from 1900 until 2010. And you can see the function b of t is the population of Baltimore in the year t, and c of t is the population of Cleveland in the year t. So we want to answer a bunch of questions about this. So you can see the graph for Baltimore is the blue line, and Cleveland is the red dashed line. So the first thing we want to do is estimate what the b of 1930 is and explain what it means in this situation. So if we want to estimate what b of 1930 is, we find 1930 on the x-axis, and then we go up to the graph for b, which is the blue line. So if we just go up, we can see that it is approximately right here on the graph, which means that it's about 800,000. So b of 1930 is approximately 800,000. So, and what that means is that in 1930, there was a population of 800,000 people in Baltimore. Okay, so that's fairly simple, fairly straightforward. We just look at the graph to determine what something means. Next thing it says, here are pairs of statements about the two populations. In each pair, which statement is true? Be prepared to explain how you know. So we have, the first one we have b of 2000 is either greater than c of 2000 or b of 2000 is less than c of 2000. And the way we can figure that out is what we can do is we can go back to the graph and we can look at 2000. So we're going to find 2000 on the graph. So it's way over here on the right-hand side. And then we just go up until we hit each graph. And so you can see that the first graph that we hit is Cleveland right there. And the second graph that we hit is Baltimore. So what that means, since Baltimore is higher up on the graph, that means that Baltimore, the population, is greater than the population of Cleveland in the year 2000. So we would say the correct answer that's true is B, Baltimore, B of 2000 is greater than C of 2000. So this one where it says B of 2000 is less than C of 2000, that one is false. The second one, it is asking us to decide between whether B of 1900 is equal to C of 1900 or if B of 1900 is greater than C of 1900. So what we would do is just go to 1900 on the graph, which is way over here on the left. And same thing, go up to the graph. And first thing we can notice is that they are two distinct points. So that completely rules out the first one where it says B of 1900 is equal to C of 1900. If they were the same, if they were equal, the two lines would actually be intersecting at that point. So that one is not true. And the only thing we need to determine is whether the second one is true or not. And since Baltimore is the blue line and it's higher up on the graph, it is greater than the population of Cleveland. So this one is true as well. Okay. So let's keep going and look at the next question. It says, were the two cities' populations ever the same? If so, when? All right, and to determine if the populations were the same, we just look for points where the graphs intersect. And so you can see we have a point here at 1910, and then a point here, and we kind of have to approximate this one. It's between 1940 and 1950, but it's a little bit closer to 1940, so I would say it's around 1944. So we have 2 points where the population was the same, and that was in 1910 and approximately 1944. Okay, so there's a fairly straightforward way to just compare two functions in graph form. Second one, we have graphs that represent wired or wireless, and this is talking about phones. We used to have phones in our houses that were actually wired and they were connected. Maybe some of you remember that, maybe you don't, because now cell phones have kind of taken over. And this graph, you can kind of see that cell phones are kind of taking over because the phones that were connected were called landlines, and you can see they're represented by the blue line, and you can see that blue line is going down, whereas the red dashed line is going up, and that represents cell phone usage in households. So for this one, the first question is estimate H of 2006 and C of 2006. Explain what each value tells us about the phones. So if we go look at 2006 on the graph and we go up to the graph, we can see that the cell phone graph is somewhere between 0 and 20. It looks like it's about 3/4 of the way. So I would say that the cell phone C of 2006 is approximately 15. And that means 15% of households have cell phones in 2006, only a cell phone. Now, if we go up to the other line, the blue line, that's the landline. And so we can see that that one is up here above 80, but not quite halfway to 100. So that means that's probably about 85. So we have H of 2006 is approximately 85%. So what that means is that the vast majority of homes had a landline in 2006, 85%, whereas only 15% only had cell phones in their homes. Next question says, what is the approximate solution to C of T equals 20? So when we're asked a question that is in this form where we have C of T is equal to a number, what we're going to look for is that number on the y-axis of the graph. So that 20 is 20%. So we're going to come over and we're going to take a look at 20% on the graph, and then we're going to go over until we hit the graph for cell phone only. And you can see it's approximately right there on the graph. And that is between 2008 and 2009, but we know it's the year 2008. So I would say that the answer is T is equal to 2008. Okay, it's approximately 2008. Now, what does that mean? It means that in the year 2008, 20% of households had cell phones as their only phone in the house. Okay. Next one, we're going to do a couple of comparisons like we did in the first problem. So in these, we're both trying to determine whether or not they're equal or not. In this case, we have C of 2011 and H of 2011. So what we can do is go find, oops, I have to erase. We go find 2011. So 2011 is right here, halfway between 10 and 12. And we need to determine whether or not they're equal or not. And it's fairly obvious if we go up on the graph here, we can see that they are not intersecting at that point. So that means that this statement would not be true. So it would be false. They are not equal to each other. And then we can go for the second one up to 2015. And 2015 is right here. And you can see in this case, 2015 is when the two lines actually intersect. And so if they're intersecting, they are equal to each other because they're at the exact same point on the graph. So we would say that this one is true. Okay, this one in class, I misread the first number to be 2014. So it says between 2004 and 2015, did the percentage of homes with landlines decrease at the same rate at which the percentage of cell phone only homes increased? Explain or show your reasoning. So between 2004 and 2015, if we look at that on the graph, we can see that the cell phone use went something like this, and the landline use went something like that. And what we can do is we can just look at those two lines and we can say, they look like they're about the same slope, but one's positive and one's negative, okay? One way we can know for sure that they are about the same slope is you can look at where they start. And so you can see this one started pretty close to 0, whereas this one started pretty close to 100, but they both ended up at approximately 50%, which is halfway between the bottom and the top of our graph. So if they both started at approximately the same distance from 0 and 100, and they ended up at 50%, then that slope is probably almost exactly the same. So the answer to the question would be, did the percentage of homes with landlines decrease at the same rate at which the percentage of cell phone only homes increased? The answer is yes. And the explanation is what I drew on the graph there. Okay, and so the next part says, explain why the statement C of t plus H of t is less than or equal to 100 is true in this situation. So if we look at this whole situation, we're going to notice that the red line plus the blue line, or the point on the red line plus the point on the blue line, is approximately 100 in each situation. So if we look at 2008, we can see the red line is 20%, the blue line is 80%, and if we add those together, they equal 100%. And it's going to be true for most of the numbers. We're going to have a slight difference probably, and the difference is because it might be slightly less than 100, but it's never going to be more than 100 because we only have 100%. When we're talking about percent, we don't go past 100, and sometimes it could be slightly less than 100 because there may be some homes that don't have a phone at all. So that would mean there's a small percentage that don't have a landline or a cell phone. Okay, and so if we wanted to explain why the statement C of t plus H of t is less than or equal to 100 is true in this situation, we could simply say that percent is always out of 100. And so it's always out of 100, but then sometimes it might be less than 100 because some homes may not have a phone at all, okay? All right, next question, it says, what value does C of t plus H of t appear to take between 2004 and 2017? How much does this value vary in that interval? Well, if we add them together, so this is kind of the same question, and the answer is it appears to take the value of 100, all right? It's because percent is out of 100, and it could be slightly less than 100 though. Like for the same reason I said before, there may be some homes that don't have a phone, so it could be 99%, 98%, but it's always going to be really close to 100. And so the question about how much does it vary in that interval, it's hard to say exactly how much it varies because if we look at the graph, it's not possible to get super precise with our numbers because the space between each line is fairly small, and we could estimate, but we might be off quite a bit because the space is kind of small. So it's hard to say exactly how much it varies, but I would guess it's going to vary somewhere between 1, 2, 3% maybe at the most. So that's one thing to keep in mind when we're looking at these graphs is it's hard to get super precise. So if we're close, that's going to count in most cases. Okay, so let's look at the next problem, audience of TV shows. This is a different type of graph. You'll notice that we have points on the graph instead of lines, and this is because it's about single episodes of a TV show. And so we have integer numbers for the TV shows. So like there's episode 1, episode 2, episode 3, and there's nothing in between those numbers. So that's why we don't have a line connecting these dots. We only have the dots at the integers. And so each one of these represents a different TV show. And so what we need to do is we need to take the descriptions down here and match each description with the TV show. So the first one says, this show has a good core audience. They had a guest star in the 5th episode that brought in some new viewers, but most of them stopped watching after that. So if we notice in graph for show C, in the 5th episode, we have this one point that's way up high. So that's going to be because of that guest star in the 5th episode, and it brought in some new viewers. So it caused the audience to be quite a bit higher for that show. But then after that, it kind of dropped back down to normal, and so that represents the part where it says, but most of them stopped watching after that. So the first description is going to go with graph C, and then, or show C. And then the second one, it says, this show is one of the most popular shows and its audience keeps increasing. Okay, and so If we look at show A, it is definitely increasing and it just keeps increasing. However, if you look at the scale on the side of the graph, each scale is a little bit different. And if you think about what it says about this is one of the most popular shows, the scale for A starts with the smallest number and has the smallest increment. So really, that isn't a huge audience in millions compared to show B and show C. So I don't know that this description really applies to any of the shows that are up there. So let's go to the next one. It says this show has a small audience, but it's improving so more people are noticing. Well, show A, if you look at the scale on the y-axis, it definitely starts with small numbers, and it's improving so more people are noticing from 1 week to the next. So you can see that kind of does represent that. So I think that we could call that description show A. And then the last one starts off, I can't draw an A. Why is that? There we go. That's a little better. The last one, it says this show started out huge. Okay, and so huge means up high. And so you can see in show B, that first point is really up high, up at the 10 million viewer range. And then it says, even though it feels like it crashed, it still has more viewers than another show. So if you look, it comes down to around 4 million viewers and hovers around 4 million, which is still more than show A, and a little bit more than show C even. So that last one is definitely show B. So we'll call that one B. Okay, and so this next question gets to this idea of that scale on the side as well. It says, which is greatest, A7, B7, or C7? So if we just go to the graph at 7 for each one, so the points at 7 are this one, oops, I kind of hit it, that one, and then this one. And then if we go over to the y-axis for each one, we can see that this one is somewhere between 1.5 and 2 million. This one is right around 4 million, and this one is right around 3 million. So the answer is B7 because it's closer to 4 million, whereas the other ones are smaller. So the answer is B7 is greater, and the reason is it's approximately 4 million or so viewers, whereas the other two are much smaller. So one other thing we need to do is that one description that we didn't use. So this show is one of the most popular shows, and its audience keeps increasing. We need to draw a graph for that. So one of the key things here is the fact that it's one of the most popular shows. So what that means is its scale is going to be greater than the other ones. So what we could do to really make this obvious is we could say, instead of counting by 2s or 0.5s, we could count by 5s even. So we go 5, 10, 15, 20, 25. And then we could just make points along the way, and we could say, all right, here we had this, and so you can see it just keeps growing. And we could say that is representative of that description. It says this show is one of the most popular shows and its audience keeps increasing. So it's most popular because the first episode started with 5 million viewers. None of the other ones started that high, and then it's continued to grow ever since then. Okay, and so that's how we could represent that description. So the main takeaway from this is that the scale that's used on the y-axis, if the x-axis is the same and the y-axis is different, that scale on the y-axis is going to make it hard to just look at the graphs and be able to determine which one is higher, because we can't make a visual comparison. We actually have to look at the numbers that are on the y-axis in order to understand which one is bigger. All right. Last thing we want to talk about is another graph here where we just have two functions on the same graph. If you want to know these two functions, the blue line or function g is considered a linear function, and the black line function f is considered a quadratic function. And we'll get into that more later. But all we have to do is decide which value in each one of these pairs is greater for the given input. And so all we have to do is find the input on the x-axis and then go up and determine which graph is higher. And so if we look at f of 2 and g of 2, so we would just come to 2 on the graph, and if we just go up, the first one we hit is f, and then the second one we hit is g. So g is higher, so that means g is greater than f of 2. And so if we do the same thing at 4, we can see when we hit the graph, they're actually the same. So neither one is greater, they are equal. So these are equal, so they are not, it's not possible to tell if one's greater than the other. And then the next one at 6, so we're gonna go at 6 and go up to the graph. We hit G first, and then we hit F. So in this case, since F is higher, F is going to be the greater value for the given input. And then if we do the same thing at 8 and we go up to the graph, we can see we get to the blue line first, which is G, and then we get to F. So again, F is greater than G at this case. So is there a value of x at which the equation f of x equals g of x is true? Explain your reasoning. And the answer is yes. And it's where they intersect. Okay, so where the two graphs intersect is where the two functions are equal to each other. So yes, where they intersect. And so in this case, they intersect at two values. The first one is at 4, and the second one is at 9. So at x equals 4 and x equals 9, those two functions are equal to each other. And then last question, identify at least two values of x at which the inequality f of x is less than g of x is true. All right, and so if we want to look at inequality here, we want to know where f is less than g. So the easiest way to do this would be just take the highlighter and say, hey, if we highlight this part, it's lower than g up to that point. And then from here to the end, it's lower than g. So any values within those two areas are going to be able to satisfy this. So we can go up to 4, but not include 4, because 4 is where they're equal to each other. And then we can start at 9 and go up to 11.5 or so, but not include 9. Okay, so any value from basically 1/2, it looks like about 1/2 to 4, but not including 4, and then any value from 9 to 11.5, but not including 9. Okay, so you could pick any value in between those two ranges and it would satisfy that inequality. All right, so that was quick. Hopefully this helps you stay caught up, and if you have any questions, feel free to let me know, and otherwise I will see you in class the next time.